Now, this is a rule that you probably know very well, but I like to make sure that I brush off the cobwebs in case there is any questions. Now, as you know, the rule is please excuse my dear Aunt Sally. Now, this guarantees that no matter who does one of these mathematical problems, they are only going to get one correct answer. Now, if you don't follow the rules, you will get a different answer, but it's not the right one. Now, there's a couple of things about these rules that some of you over the years have kind of forgotten. And it's going to come into play as you work on some of these particular problems. Now, the first one, as you see, says please. Now, for our class, there is also an order for what we call grouping symbols. Now, just to give you an idea, we are going to have and see parentheses. That's normal. Then you are going to start to see what we call brackets. And then we are going to have braces. Well, the key with this grouping symbol is that we start with the parentheses inside the grouping symbols. And then we work outward, which means we then, once we've done the parentheses, we do the brackets. And then we finish by doing what's between these braces. So we basically are going inside out when it comes to grouping symbols. Now, we have then also excuse. Well, excuse is going to deal with exponents and roots. And in case you've forgotten, a root symbol is this funny symbol. It's got like a little check mark in front. This is going to be done next. Now, this is where on the last two steps that people have trouble. It says, my dear. Well, this is the rule that you may forget. It's multiplication and division are done from left to right. And this is the phrase that some people forget. Comes first. That means if division comes before multiplication, I'm doing division. If multiplication comes before division, I do multiplication. But the key is, as I read the mathematical line from left to right, I find which symbol comes first, division or multiplication. And then the last one is Aunt Sally. Well, this again talks about additions and subtractions. But again, they are done from left to right, whichever comes first. And those phrases, comes first, is what may get you in trouble. Now, some problems you can do the wrong way and get the right answer. It does happen with some of these, but you will find that if you practice or use the incorrect method of please excuse my dear Aunt Sally, when we get to other algebraic expressions, they are going to be done incorrectly, and you're going to struggle with why did this happen? Well, hopefully in the next couple of slides, I'm going to do several problems that deal with order of operations, and I'm going to try and help you understand these rules. Now, on this particular slide, just like you will see in Pearson, I have 3 numbers. Now, they're all done in the same order, but what's happening is the operations between them are different. Now, some people like to write over here on the side, please excuse my dear Aunt Sally, to remind them that is how we do these problems. Now, you may find that when you do this in Pearson, they're just going to give you the word simplify. They're not going to tell you use order of operations because it's believed that you know this order of operations has to be applied. Now, let's look at the first one. Now, the first one, I have no parentheses, I have no exponents, there's nothing to multiply or divide. Now, when I do this, notice down here, I'm at the add or subtract line. I am going to do the subtract first, which means that I'm going to get 12 plus 2, which gives me the answer 14. Now, I want you to notice something. If you did the add first, you'd have 16 minus 6. Well, that would give you 10. 10 is not the correct answer. 14 is the correct answer. Now, let's take a look at this one. Add is coming first, which means that I will have 20 minus 2, which gives me 18. Now, this problem, you could have done 4 minus 2 first and then added the 2. That's doing it incorrectly, but notice I'll still get the same answer. You don't want to practice that. You want to practice the fact that it's add or subtract from left to right, whichever comes first. Now, let's look at the last two. I have, in this case, a division followed by a multiply. We are looking at multiply and divide, but remember, I am going to divide first. This will give me 4 times 2, or 8. If you do the multiply first, you would have gotten an answer of 2. 2 is not correct. Answer is 8. And then again, right here, 16 times 4 is 64 divided by 2. My answer is 32. Order has a place. Now, we're going to try these, but be careful. This is bringing in some old stuff with some new stuff. Okay? Now, this is still telling me to simplify, but notice here I have parentheses, I have exponents, I have an absolute value, and I have braces. Now, you have to remember that this negative in front of the -3 is saying take the opposite of a -3, which means that this problem is really 4 plus 3. The answer is 7. Now again, be very careful with this one. Now, if you need to write it, because what I have here is absolute value, this is saying 4 minus. Now, the absolute value of a -3 is going to be a +3. That's what that yellow symbol means, the bars. Well, now I'm taking 4, but I want the opposite of. Remember this little symbol of negative right here means the opposite of a +3, which means I have 4 minus 3, or the answer of 1. This negative sign means, and don't forget, the opposite of. It's coming in front of a parentheses, but the parentheses happens after I take out the -3 from the absolute value bars. Now, this one. Some people, I'm not sure why, have trouble with this, but I'm going to show you a way that you can kind of avoid it, or at least I'm hoping so. This little 2 pertains only to the -3. So what I have here is 4 minus -3 times -3. That's what that 2 means. It means I have 2 of these. Well, I have to deal with the exponent. And remember, a -3 times a -3 is going to give me a +9. But then don't forget, this negative is saying I want the opposite of, which means I have 4 minus 9, which gives me a -5. Now, we have to deal with what's inside here. This symbol right here is saying take the opposite of -3. So inside the brackets, I have 4 plus 3 with a little 2 on the top. Well, 4 plus 3 is going to give me 7 inside the brackets. And then I square it. That square is 7 times 7, or the answer is 49. Watch out for this phrase. It's going to be around for the rest of this course, and if you take further courses, it applies the opposite of. Now, let's do some other ones. Okay, 4a. We have no parentheses, but we have an exponent. Now, some people like to write this line that says 3 plus 5 times 5, because that's what that 2 means. And remember, order of operations says that I multiply, which means that this is 3 plus 25, or 28. Now, this line is one that if you choose to write it, that's up to you. Some people can go from the top line right down here. That's fine. Or they can even tell me the answer is 28 right away. but it's up to you. How do you need to get to the correct answer? Now, this is one that people have trouble with. Notice that I have 7 minus 3. We don't do that because if you remember, the order of operations is please excuse my dear Aunt Sally. We have a parenthesis, which means that's 7 minus 3. I'm not touching. I have to do what's inside here. Well, this is saying 7 minus 3. Well, 2 minus 6 is a negative 4 squared. That's the parentheses. Now, the next step is the exponent. That's that 2. And that 2 only pertains to negative 4. Do not take the negative 3 and the negative 4 and multiply them together. No, 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 no. Order is not saying that. It's saying 7 minus 3, and it's negative 4 times negative 4, which means that these two, when I put them together, will give me 7 minus 3 times a positive 16. Now, I have multiply or divide, but I have a multiply. That is these two numbers. This is 7 minus 3 times 16 is 48. Add or subtract comes last, which means that we are subtracting. Which means my answer is a negative 41. If you got something very different than negative 41, you did not follow this order. You got to get negative 41. We do the parentheses first, which was the yellow. We take 2 minus 6 is a negative 4. Then we have negative 4 squared. That's why I wrote the 2 negative 4s. But a negative times a negative, as you remember, is a positive 16. Now, that 3 next to the parentheses means multiply. Notice I never took 7 minus 3 and made it a 4. No. Because order just had it sitting off to the side. So be careful of this type of a problem. Now, let's look at these two. Now, these two, problem C is what we call a three-parter. You do the top. Now, in this case, we're very lucky. We have a single number. And then we would then get a fraction. We do the yellow first. If there's more than one number in the denominator, we put them together, and then we finish by dividing, because that's what that line means. But since I only have a lowly 3 in the bottom, that stays. Now, this one, you're taking the numerator only. just here, because that answer has got to go above the 3. Well, this will give me 18 minus 8 times 4 squared. Order of operations. I don't have any parentheses, but I have an exponent right here. So this is 18 minus 8 times 16. Notice I did not take the 18 minus 8 and write 10. No. Order doesn't say I can do a subtraction yet, but I can take 8 and 16, which is going to give me 18 minus 8 times 16 is 128. This is going to give me a negative, in this case, 110. Now, that's what's going above the 3. Now, this improper fraction is a good answer. Because can I reduce or simplify? Yes. And notice these instructions don't ask me to write it as a mixed number. So I don't want to do any more than write that fraction of negative 110 over 3. Because it's a simplify. Simplify means make as small as you can. Well, negative 110 over 3 is as small as I'm going to get. Now, next one. Parentheses are going first, which means I am doing this first, which means I have 2 plus 8 squared minus, well, inside the parentheses, I'm going to get a negative 3. Okay. Then I have an exponent. This is going to give me 2 plus 64. Now, in this case, right here, I have a negative 3. Well, negative 3. Well, here we go. Negative 3 is going to give me a positive 3. Now, 62 plus 2 plus 64 is 66 plus 3, or 69 is my answer. Okay. Now, these you got to be careful with. Okay. First off, we have a fraction. You got to do the numerator first. Well, this will give me 4 cubed minus, now, 16 times 4, because 2 squared is 4, is 64 over 4. Well, what is the square root of 64? Well, this is 4 cubed minus 8 over 4. 4 cubed is 64 because it's 4 times 4 times 4, which is 64 minus 8 divided by 4 is 2, which gives me 62. That radical, because it has several terms underneath it, it's kind of grouping. And the same thing is going to happen with F. Okay? I am going to do what's under here first. Okay? Well, this gives me 5 squared minus 4 times negative 3 times 2. Well, these two give me a negative 6 times a negative 4. Okay, negative 6 times negative 4 gives me 5 squared minus a positive, because negative times negative is going to give me 24. 5 squared, because remember, I have all of this stuff underneath. Negative times negative. I have an even number of negative signs. That's a positive 12 times 2 gives me 24. So 5 squared is 25 plus 24 is 49. What is the square root of 49? The answer is 7. So I have a negative 4 plus 7 over 2. This will give me, putting these two together, I will have the answer of a positive 3 over 2. Notice all of this was for that lovely square root that we had. Everything under the yellow was a positive 49. 49 then became 7. Negative 4 plus 7 is a positive 3 over 2. Now, this last one, oh, I know you're going to like this one. This one has fractions. Okay. Fractions. Now, we start with the parentheses. We do what's inside here. Well, you have to remember, when you subtract fractions, you need a common denominator. So dealing with what's just in the parentheses, I have to make both of these a 25. Five times 5 is 25, which means 1 times 5 is 5. This problem becomes 2/3 squared minus, now put these two together and they go inside the parentheses, which is 425 divided by 3/2. Okay? Now, fun time. We are dividing next. Or wait a minute, take that back. Okay. we are going to do my exponents next. Ooh. This is 4/25 divided by 3/2. Next thing is this exponent. Well, this exponent happens to give me 4/9 minus. Now, what am I going to get over here? I have, in this case, these two blues have got to go here, which means I have 4/25. Now remember, this fraction flips, which means that this behind the negative is 8/75. That's the blue. These two go next. I do exponents and then I do divide. But again, what happens? I am subtracting again, and I have two fractions. Now, you're going to like this one. My common denominator happens to be 675. Well, 9 times what gives me 675? Well, it's 75. So if I multiply this by 75, I have to multiply 4 by 75, and I get 300. If I take 75 and multiply by 9, I've got to multiply by 8, which is 72. Now, my common denominator is 675, and 300 minus 72 is 228. Now, this is where you have to know that this fraction, 228 over 675, can be reduced. I can divide by 3, which means my final answer is going to give me 76 over 225. This is my answer. And notice I had a lot of subtraction. Okay. Now, my last one. Okay. Now, this is really a 3-parter. I got to do the top, got to do the bottom, and then I have to remember that I'm dividing. Well, let's do the top, okay? We have a negative 35 parentheses negative 3 minus a negative 20 times a negative 3. This is going to give me my answer for the numerator. Okay, order matters. Negative 35 is next to negative 3, which means that I'm multiplying two negative numbers, which will give me a positive 105 minus a minus -20, -3. I did these two first. Well, now I need to do these two first. Well, this is going to give me 105 minus -20 times -3 gives me a positive 60. Well, negative, take the opposite of. So this is 105 minus 60, which gives me 45. 45 is the number that's going up here. That is a positive 45. Well, now I need to take -3, 1, -2, 1. These two are going together. This will give me a -3 minus 2 times 1. But remember, these two have to go together. They're multiplying. This will give me -3 minus 2, which gives me a -5. So that means that this denominator right here is -5. Now divide. What does that red line mean? -9 is my final answer. Yay! Okay. Now, these next couple of slides all are going to ask you to evaluate. Now, this is where you got to make sure you know your order of operations. It says replace each variable in the formula with a parentheses. Now, you may think it's a waste of time, but it does make a difference when you're dealing with positive and negative numbers. Inside the parentheses, replace each variable with the appropriate numerical value, which means the algebra god is telling you what is x, what is y, what is z, what is k, what is m. They're telling you. Now, this is the part that people forget. You're going to use the order of operations to simplify, which means you are using please excuse my dear Aunt Sally. That's coming into play. And then they're going to say, state the result, which is your answer. Now, sometimes you have to give appropriate units with your answer, and that's all going to depend on what the problem is. Well, I only had a couple more slides, and here we go. This is saying evaluate. Well, this is saying that my x is -2, which is right here. That's my 2. But notice it has an exponent. You may find doing this will ensure you always get the correct answer, because this is now 2 minus 3. Well, notice that x has got a power of 2. Notice how many parentheses I wrote. 1 for each -2. So I'm going to put -2 here, -2 here. Well, we know that the denominator, because it's a single number, is staying. But order of operations is saying we're going to multiply these three. -3 times -2, that means these two go first, is a +6. But a +6 multiplying by a -2 gives me a -12 with this 2 out in front. Do not put the 2 and the -3 together. No, 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 no. Because this will then give you a numerator. These two numbers will now become a -10 over 2 or -5 is my answer. If you put this 2 and 3 together, you're not going to get the correct answer. Order of operations matters. Now, this is where the units are coming in, okay? Some people are not thrilled with this, but the units do come into play. And in this case, they say use the formula to convert 100 Celsius to Fahrenheit. Well, what they're saying is this nice little C is 100. So we are going to do a little rewriting. This is F is equal to 9/5 parentheses plus 32. Now, I'm going to put in 100 over 1. Now, why did I do that? Because this is a fraction. This fraction has to multiply by a fraction. And hopefully you're going to recognize that I can cross cancel. If I divide 5 and 100 by 5, I get 20. So this will give me 9 times 20, or 180, plus 32, which is going to give me 212 degrees Fahrenheit. This is my answer, because these two have to be multiplied first. Okay. Now, my last one is a wonderful story problem. And you are going to have story problems very similar to this. But you need to be able to read it and translate it. Because remember, translation is a big part of our course. Now, this particular problem says the dosage of a medicine prescribed for a child depends on the child's age. Now notice, they're using child's age as the letter A. And the adult dose, D. Notice, D. So I have A to represent the child, child's age, and adult dose is D. And notice in this formula, a little bit further down, I have DA. That means the adult dose times the child's age. Now, this is known as Young's rule, is a formula used by pediatricians to give a child's dose, C. Now notice, we got another little letter here, child's dose C, as C is equal to D times A, because when two letters are next together, they mean multiplying, and divided by A plus 12. Okay, here we go. Suppose the 5-year-old child, that is telling me that A is equal to 5, okay? The normal adult dose which is telling me that D equals 1,500. So with that information, C is equal to 5 times 1,500. Now remember, A is 5, so this is 5 plus 12. Well, we got to put the numerator together. This has got to go together first, which is going to give me 7,500 divided by 17. Now, unfortunately, it says, what size dose does the child receive? Okay, you see this little problem? It means that you're dividing 17 into 7,500. Now, you are going to get, in this case, a mixed number. This mixed number is 41 with a remainder of 3/17, okay? And in this case, milligrams. Now, this is the exact dose. But remember, dose 3/17, how would a nurse or a doctor or a pediatrician know on a syringe where 3/17 is? Well, you may find that Pearson will round this to a whole number of 441 milligrams. Now, you don't want to round up because that might be a little bit too much for the child. It's better to be safe, as the saying goes, than sorry. Rounding to 442 milligrams is a problem because it's giving the child a little bit more than he might not be able to tolerate. So look at the answers in Pearson. Some of you are going to get 441 3/17 as an answer. But Pearson may also find and give you the answer of 441 milligrams. What's more important, more appropriate? The 441. Now do take care. This ends section 2.5. Have a good day.